All right, I'm back. We're on page 317 of notes 22. Well, of math analysis. Really, we're in notes 22, the last set of notes. It's very exciting. What are we going to do? We're going to find the x-coordinates of all extrema of g of x equals 3x to the fourth plus 40x cubed minus, this just took a turn, 0.06x squared minus 1.2x. And then we're going to classify them. So, and then it says, is it really even possible to graph this in a good window that shows all of its features? I don't know. Let's find out. So we need the derivative. So I'm going to say g prime of x is 12x cubed plus 120x squared. All right, minus 0.12x. I'm going to change that to a fraction, I think, and then minus 1.2. All right, so I just power ruled my way through it. It's like, it's not great. So let's see. I'm going to make this 12x cubed plus 120x squared. I'm going to make this minus 12 out of 100x. And I'm going to make this 12 out of 100. And then, what should I make that? 120 out of 100? Okay. Then I can take out 12 over 100. So let's see. I'm going to factor by grouping. So I'm going to do these together. And then I'm going to do, that's not like an exciting color. You don't even know what color I chose, but it wasn't exciting. So I'm going back. Then I can group these together. All right, so grouping the first thing together, I'm going to take out 12x squared, and that leaves me with an x plus 10. Okay, and then whatever I take out of the next set, it needs to leave me with x plus 10. So like that's kind of reassuring. So I should take out minus 12 over 100. And does that leave me with x plus 10? It does. All right. So now I'm going to factor this by grouping. They both have an x plus 10, so I can take that out. I can actually, you can take out, well, let's do it. So x plus 10 and 12x squared minus 12 over 100. So I can pretty clearly take out another 12. So I'm going to do that. I'm also going to move this up a little bit, just to like give me some breathing room here. Maybe move all of it up a little bit. It's my favorite part of writing on an iPad is like when you don't space it out correctly, you have a little leeway. So I'm going to take out a 12, and then I still have an x plus 10. And then here, I now have x squared minus 1 over 100. There's actually a difference of squares. It's like not the kind you're used to, but it's still a difference of squares. So this give me 12x, x plus 1/10. Holy cow, x minus 1/10. So now I understand the question a little better about, is it possible to graph it with all the features in the same window? Probably not, because of the scale of the critical points, right? So, oh man, I wrote it wrong. This is supposed to be, let's iPad magic. Right. Okay, this is supposed to be x plus 10. So plus 10, parentheses. You'd never even know it, right? If you're not watching the videos, if you're just scrubbing through them and pausing, you'll never even know I messed that up. Great. All right, so critical points. Here we go. Critical points, x equals -10, x equals 1/10, x equals, what happened there? No idea. I'll just write over it. X equals -1/10. Okay, those are my critical points. Now let's sign chart this thing. So this will be for g prime. My inclination is to name every function f, and that's probably yours as well. Make sure you're reading the problems. I mean, usually it's not killer if you mess it up if there are no other functions, but a lot of problems you do in calculus have an f and a g, and so you got to really make sure that you're doing the right thing. -1/10, nope, -10, -1/10, and 1/10. All right, so -1 billion gives me negative, 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 3 negatives. So negative, and then everything is to the first power, so they're going to alternate. Really, it's everything is to an odd power, and so they're going to alternate. Or you just keep checking. Conveniently, 0 is in between -1/10 and 1/10. Sometimes it's really tricky to come up with a value that'll work. So where do we see positives and where do we see negatives? So positives here and here. And then our negatives are here and here. And so I know what's going to happen, right? I know that g of x has why does that keep happening? And also, like, there's so many of them. Has relative, all right, so relative minimum at, all right, where are the relative minimums? It's where the derivative goes negative to positive. So that happens at -10 and at 1/10. So at x equals -10 and, no room there, and x equals 1/10. But why? Why does it have those? Let's say because g prime changes negative to positive at those values. And then g of x has relative maximum at x equals -1/10. I keep scrolling accidentally. At -1/10 because g prime changes positive to negative there. Okay, so I've found and I've classified the critical points. Now I think that the logical thing to do is to see on the calculator like what this looks like. So let's see if we can do that. I'm gonna switch over. I'm gonna graph g of x. So I'm just gonna do a new problem. All right, so g of x is 3x to the 4th plus 40x cubed minus 0.06x squared minus 1.2x. All right, then we want to graph this. So doc 4, graph g of x. Okay, so they're like, so you can barely even see it, but okay, here are my minimum and maximum, right? So that's 1/10 and -1/10. So we thought there would be a maximum at -1/10, and that definitely looks right, and a minimum at 1/10, and that looks right. But what about at x equals -10? So I'm going to zoom out to see if I can find that. All right, so zooming out is, I mean, let's try it for another couple. All right, it's coming into focus. Holy, okay. All right, here's a little trick that we can use. So if we go to menu, option 4, Windows settings, I know that like I really want like -12 to like 4 or something like that, right? My minimum value is what I'm searching for. So what I'm gonna do is I'm gonna say to make that F1 of, I know that at -10 is what I'm interested in. So I'm gonna do that and then minus like 100 and see what happens. And then the maximum, I don't know, I'm gonna make 500 and like hope for the best. All right, let's press enter. Okay, so that like almost worked. I mean, you can see it, right? So we can see the minimum. So the problem with this function, if we didn't have calculus, we would never know what's happening around 0 if we can see what's happening around -10. We would never know what's happening around -10 if we can see what's happening around 0. So without calculus, we wouldn't know where these critical points are, and we'd be in trouble. But because we know the calculus, we could find the critical points, and it's not that bad. Like, we know how to search for it. So what I'm gonna do is I'm gonna end this video here. I'm gonna come back in another video, keep going on this page, because I feel like this maybe took a little longer than I intended. I don't really know. Anyway, I'll see you in the next one. So come back for more.